Good afternoon, all. I think now all of you have joined. Still few are yet to join. Let us restart with our experiment. Uh, Today we are going to take our next experiment number. That is, I think, experiment number 8, right? So, in last lab session, we had taken experiment number 7. That is regarding the sorry. That is regarding the encoder circuit and decoder circuit. So, that was our experiment number 8. That is what we have taken in last session. That is encoder and decoder. Now, today we are going to take the circuit that is experiment number 9, and that is circuit which is we are going to talk today is belongs to the sequential circuit of digital part, and that is we are going to start with the basic information of sequential logic circuit, and then we'll take the first block, or you can say the basic block of the digital sequential circuit, that is the latch. Okay, so today our experiment aim is to understand the working of RS latch, okay, using NAND gate and NOR gate. So if I just share with you, so here is the aim of the experiment. Today we are going to talk, that is the construction of NOR gate latch, and also we will be discussing construction of NAND gate latch, that is using this, and we'll be verifying its operation. So before we start discussing about the latch, what is the meaning of latch? Yes, anybody of you can give me the. Have you ever come across this kind of sequential circuit, or any information you got regarding this? Yes, any one of you have any kind of knowledge regarding this sequential digital circuit?
It is a power storage unit.
No, Mohit, it is not. We are talking about digital circuits, so there is not any kind of power storage taking place, right? So it is ultimately going to be the storage of digital information only. So yeah, your point is clear that there is something about storage, but not about the power storage. Okay, so let me tell you about that first. That in the digital circuit, if we classify them, then basically we can classify them in two parts, that is combinational circuits and sequential circuit, right? Till now, the circuit which we have discussed, that is all are based on combinational circuits, right? For example, if you take the example of half adder, so in half adder also we have discussed circuit that is only depending on inputs present at the time, right? What I mean to say by that is, suppose you are having a half adder circuit like this, sorry, in which you are giving the two input signals, or you can say two input numbers, that is, let us say A and B, and that half adder will provide you the two outputs, that is, you can say sum and the carry, right? Or you may call it the C out. So in this half adder case, we can see that the output of this circuit, that is sum and carry, is depends on only the present state of this A and B, right? What I mean to say by that is, suppose you are giving your input A like 1 and B is 0 right now at present. Now you consider the thing we are talking in belongs to with respect to time. So if you are giving the value 1 here, sorry, or if I just show you the plots, can be like this, you can have, right? For example, here on x-axis we are taking the time, okay, and and on y-axis we are taking the different signals. For example, here your signal A is there, and that is going to have value like this, suppose. Okay, and suppose your value B. I just draw the value B. You can say something like this. Suppose if it is like this. So what do you mean by this? Here it is, you can say logic 1 is there, here logic 0 is there, right? Likewise, here is 1, here is 0. Same thing you can say here is 1, here is 0 for the signal B. So these signals we are plotting here with respect to time. And now if you want to plot your sum output, that is what we are getting at the output of this half adder. So what that will be? You can see that your sum output from this instant to this instant. You can see here your B is also 1 and A is also 1. So 1 plus 1, your sum is going to be 0, right? After that, up to this point, you can see that your A is 0, B is 1. So your sum is going to be 1 there. Likewise, from this instant to this instant, your A is 1, B is 0. So sum will remain 1 as it is. Then after A is also 0, B is also 0. So your sum is going to be 0 here at this point, and it will remain 0 up to this instant, like this, right? Then after, for this instant again, they both are going to 1. So it will remain 0 here again. So like this, you can see the sum output for this half adder circuit, which you are getting over here, is going to depend on present value of A only. Yes, who is there? Hello. Okay, so what I'm discussing here is about sum or half adder circuit, and that half adder circuit will give you the result sum, which depends only on the present condition of your inputs, right? That you can see here also, that for this duration, for this time to this time, let us say, you can say, if I give here time 0, and here let's say if I'm saying time t1, whose, hello, whose audio is on? Among your audio is on. Hello. Hello, Amang, can you hear me? Okay, so this is what I'm saying to you, that from 0 to time t1, whatever sum output we are getting here, that is the result, or you can say output of this circuit. It depends only on the present condition over here on the input side, that is A and B, what the value is. But this sum output which you are getting here in this time is not going to depend on what the previous value of A and B was, or what is going to be the next value of A and B. That's not going to be depend on that thing, right? So instead, present means at that particular moment we are talking. So this is what it is, a combinational circuit, right? Half adder is what? It is a combinational circuit. In this combinational circuit, we are having only various type of combination of logical gates. There is no any memory included in that circuit. In this combinational circuit, only there is a various type of combination connections of various logical gates inside. That's it. And that is why the output of the circuit will only depends on present state of the input signals. It do not depends on the previous output of the circuit, or you can say previous input of the circuit. And that is why it is called combinational circuit, and there is no any memory role involved. So am I clear about this thing to all? What about combinational circuit is? And have you understood clearly what the present state or present input condition we are talking here for? Hello everyone. Can you get it understood or not? Hello,
Yes,
I'm
sir, it's
getting,
clear. Yes, yes.
right? So when I do say present input means the input coming at that particular moment for which you are referring at the output side. Okay, so that's what we can say present condition of the input side signal, and that is going to happen in case of combination circuit, that your output will only depend on the present input of the signal. So if I just draw the block diagram in general you can say your combinational circuit can be represented like this, that this is your combinational logic circuit. What it will do, it will take the input here. Okay, so that is what your present input here, and you will be getting the output from that circuit itself. So this is the part of your combinational circuit. Means inside the circuit there is no any memory unit, there is no any other kind of information storage going to be takes place. Whatever input you are going to supply, according to that you will be getting the output. That's what we can say a combinational circuit is. Now the second type of digital circuit, it is known as the sequential logic circuit. It is combinational circuit, and now we are talking about a different type, or it is another type of your digital circuit, that is called as a sequential logic circuit. Now in sequential logic circuit, you will be having one more block, and that block we can say it will be of a memory part. So I can have one small block here, and I can say it is what? It is your memory, or you may call it a memory unit. So what this will be doing? In this case, your output will be given to the memory unit, and that memory unit will be supplying another input here, like this. So it means what here? Now the overall circuit, this overall circuit can be said to be a sequential logic circuit, right? So this is what is your now sequential logic circuit. That includes combinational logic circuit as well as memory unit. So what it will be doing? It will give you output based on your input, as well as your circuit is now having capability to store the information. That means the information about what was the last output. Understand this thing, everyone? Now your circuit is having capability to store. There will be a memory unit, there will be a memory part inside your circuit that will be able to store the value of output. Value of the output, that means the digit, whether it is 1 or 0, whatever you are getting at the output side in their circuit. So that output, your memory unit is going to be stored, and that is going to be now taken at the input of that circuit again. It means now the output of your circuit at present will depend on input of that circuit at present, as well as the output coming from this memory unit. That is what we can say, which is proportional to the last input, or you may call it as a past input. Am I clear with this thing, everyone? That what the difference between the combinational logic circuit and what the sequential logic circuit is? That in sequential logic circuit we are going to have the inclusion of memory unit, and that is why it is going to give you output which is going to depend on two parts. One, that is what your present input going to come from the input variables, and second input given by your memory unit, that is based on the last output your circuit has given. Obviously that last output which your circuit has given was depending on the previous outputs or previous inputs. So am I making this thing clear to everyone? That what the
Yes,
difference
sir.
between combinational circuit and sequential logic circuit is?
Yes, sir. Clear.
Okay. Now,
Sir, but one doubt is there.
yeah, please ask me.
If we do not have the answer of or the output of the one, we cannot find the output of the other one, and
What do you
vice
mean?
versa. So how can we do that?
I'm not getting your question exactly. What you want to ask? Can you just pardon your question again?
If we want the answer of the second one, we have to have the
Second one
answer of
means
the
you are
first.
asking me for sequential circuit, right? This one.
Yes, yes, yes.
Okay. Now in sequential circuit, what you want to ask?
if we want the output of the second one, and
Okay, you
we
want
have,
output here. Okay.
so we also need to have the answer of or the output of the first one.
First one means previous one.
Yes,
Means this combinational circuit unit you are asking for, or memory unit?
I'm asking from the combination one.
Yeah, of course, you need to have output from here also. That's what exactly you are getting at the output side, right? Ultimately, this memory unit is not going to give you anything output here. You can see this. This is not going like this. Okay. Your memory unit is taking the output. See, this is a single tapping, you can say like this. So whatever output going to come from this combinational circuit, that is going to be passed to your output. Okay, listen one thing. Now, whatever output given by your combinational circuit, that is going to be stored in your memory. It means that information will be kept by memory unit, and that information will be further applied at the input side. That's what memory is doing. And because of this, now the output which is going to be given by this combinational circuit over here will be depending on two things. One, that is what coming from here input side, or you may call that input variable side, and second thing, that what given by memory. So on that two parameter, your combination circuit is going to now work and give you the output. Am I making this thing clear again?
Yes, it is clear now.
Right. So ultimately, final output what you are getting from this circuit is taken from that combinational logic circuit itself. But here the case is different. Your combinational circuit is not only going to get the input from your input variables. It is also going to get the information of the past output which has been stored in your memory unit. So now based on that two inputs which you are getting at the input of combinational circuit, your output is going to be decided. Is that clear now?
Yes, it is.
Okay. Is there anyone have any other query here? Okay. If there is no any query, let me move further. So now, what this exactly I have given you the brief about the difference between the combinational circuit and the sequential logic circuit. Now, before we have started discussing about combinational circuit, we have discussed about different types of logic gates, that is AND or NOT, NAND, NOR, exclusive NOR, right? There are all various logic gates. And in that combinational logic circuit, till now, whatever circuits we have discussed, that is adder, subtractor, comparator, right? In all that circuits, what we have done is we have made the various combination of all that logical gates. So that combination of that logic gates has made us to have the different kind of logical circuits, and that is what we have known as a combinational logic circuit, right? So that all the circuits which we have discussed till now, that is encoder, decoder, comparator, multiplexer, demultiplexer, half adder, full adder, half subtractor, full subtractor. These all the circuits what we have discussed here, that is all belongs to the category of combinational circuit, because in all that of circuit, your output is going to be depending only on the input variables, not on the memory output, because there are no any kind of memory we have discussed in that circuits. Okay. Now we are starting our second part of this digital circuits, that is the sequential logic circuit. And in this sequential logic circuit, we are going to have the circuits that is going to give you output, as I said, based on the input condition as well as past output condition. And for that, we have to include the memory unit. That is one side thing, please clear. Now, second thing which I want to tell you is, like in combinational circuit, we were having logical gates as a building block of your circuit. What do I mean by what do I want to say by that means that whatever the combinational circuit you want to develop, whether it is the multiplexer, demultiplexer, half adder, full subtractor, whatever it is, in all that circuits, what the circuitry part you have to use in that is the different logic gates, right? That's why you can say that all logical gates you have to use in that combinational circuit, and that's why it is going to be your smallest unit of your combinational circuit, from where you will start developing your whole combinational circuit. Likewise, in the sequential logical circuits, there will be a smallest unit of that sequential logical circuit we can have, and that is known as the latch. The word we are using for that is latch. Latch means it's going to give you output like this, what you are getting here in the combination circuit, but its output is going to be set and reset. Set and reset means your output is not going to be resetted until you give the inputs. Remember this thing. Now the next part of circuit which we are going to start, in that, now let me just give you the block diagram so it will help you to understand better. So suppose I am going to show you here a latch. In the latch, there will be two types of output. Let me call here it is a latch. Let me just write it down here. Generally, we are going to talk about RS or SR latch. So what this SR latch will be doing? In the SR latch, there will be two inputs. The two inputs are, you can say, one that is what you can say reset, and other input that is you can say set. Okay, so these two inputs will be given, and obviously there will be two outputs also. One that is what you can say Q, and other one is Q bar. Ultimately, this two output is nothing but inversion of one. Means you can say one output, but having inversion condition also. Q and Q bar both are going to be getting that. So what this circuit is going to do? In this circuit, for example, if you are having output logic 0 here at Q, then obviously your Q bar is going to be having logic 1, right? So this is, let us say, initial condition at the output of your SR latch. Latch means you can call this as a sequential circuit. Okay, this is your smallest unit of your sequential circuit that is going to set and reset its output bit based on input condition. Okay, sequential. Let me just rewrite it. It's better to write it here like this. Sequential circuit. Okay, you may call this as a sequential logic circuit unit. Unit means smallest part. So that latch is going to be like that. Like in the combination circuit, you are using logic gate like AND or NOT. In that way, in sequential logic circuit, you are going to use the various latch. That latch is also sometimes known as the flip-flop. Flip-flop means its output, that is what here I mentioned by Q. It is going to be either set or reset. And that's why here it is name given SR latch. That is set reset latch. And that output Q here, initial condition we have assumed that is 0 and 1 at the output side, right? Obviously, when you consider your output Q equal to 0, that Q bar is going to logic 1. If you consider Q equal to 1, that Q bar is going to be 0, right? Because that is just the inversion operation. Now, from this initial condition, if I want to make my output Q to be logic 1, then what I have to do is I have to give the set input. That means if I give here input set value, that is S to be logic 1 and R to be logic 0, then what it will be doing? It will be making your output Q to change from 0 to 1, and at the same time as Q is changing from 0 to 1, your Q bar is going to change from 1 to 0. Now, till the time you are not going to change your input here, your output Q remains here 1, even after you remove these inputs, right? That means even if I make both the inputs 0, 0 here next, it's not going to make it set or reset. It will keep this 1 as it is over here, and it will keep this 0 as it is over here. Means there will not be any change in the output unless you give that change command on the input side. Now suppose if I want to make this 1 to 0, I have to give here reset input to 1 and set input to 0. That will make you flip-flop or latch to reset, so it will be getting output 0, and when it will be getting 0, your QR bar is going to be 1 like this. And after that, if you further remove this signal, means if you keep on giving 0 0 input here, so till the time you apply 0 0 here, that means no input is applied to the input side. Your output will be remaining at this condition, that is 0 and 1. There is no any change in that. Further, if you when give the set input to 1 and 0 here like this, then it's going to be changed from 1 to 0 like this. So this SR latch or flip-flop, you can consider it like a memory, or you can say 1-bit memory. So what this is going to work like, it will be working like a memory, right? How it is working like a memory, you can see that unless you give the input on this side, your output is going to be kept constant at whatever logic it was set by the input condition, right? And that's why the data which is going to come at the output of this circuit, that is Q and Q bar, will be kept as it is, whether it is 0 or 1, unless you give some change on the input side. And that's why it will be known as the memory, right? As your data bit which is coming at the output Q is remaining there for longer period of time, that's why it is called the, you can say, memory side or memory part. Am I making this thing clear to everyone? What this latch is there, SR latch or RS latch, what you can say it for?
Clear, sir.
Right. So this latch means it is the smallest part of memory. This type of many number of latch when combined together, it's going to increase your size of memory. Like when we have said like 1-bit memory, it is 1 SR latch. If you say 8-bit memory, it will be having 8 SR latch there inside. So that is going to store 8 bits. Likewise, when you can say I have a 1 MB, 1 MB means 1 megabyte. 1 megabyte means, I hope you know all that things, right? That 1 byte is equal to 8 bit. So when you say 1 megabyte, 1 MB, that means it is 8 bit, 8 megabit, right? So at that time you need to have 8 mega number of SR latch developed into that small memory size. So I hope that you are getting what I mean to say by this thing, that ultimately this is what going to be having the smallest part of your memory circuit that will store 1 bit of information, either 0 or 1. Now as per your requirement to store the data, you need to have many number of latch inside your memory circuit. So this is what SR latch. Now the question is that how can we have this circuit? How we can have this SR latch developed? So for that we have to know that circuit, that how this latch can be developed. So this SR latch can be developed by using NOR logic gate also, and it can be also developed with the help of NAND logic also. So let us see one by one then. So first of all, let us me to take you here in the circuit of this line. Okay, so look at this page here now. Here, this is the first case you have been given, that is SR latch. It is known as SR latch, set reset latch. What will be there inside this SR latch? You can see here. There will be 2 cross-coupled NOR logic gates, or you may call there is a need of 2 cross-coupled NAND gates. As I said, it can be developed using NAND gate also, or it can be developed as using the NOR gate also. So here it is shown the circuit with the help of you can say NOR gate. Let me take this in the side we are discussing, so it is better for you to have, because I can put an annotation there. Okay, so let me take that page here. So I'm taking this here. Now here you can see what here it is done. This is the SR latch using, you can say this is SR latch using NOR gates, or you may call it as a cross-coupled NOR logic gates. Then after we'll be discussing about SR latch using NAND logic gate. So here, how this is going to work, understand this, that is a more important thing for you. You look at here the table. This is called, you can say, truth table for the SR latch using NOR logic gate. So how this is going to work? Initially, let us say we are setting our inputs R and S to be 0, 0. Your R is 0 here, as well as your R set to 0 and S is also 0. And here, if you look at in the table, in table, here first column is giving you the inputs, that is from here, right? R and S, what we are providing here at the input side of this latch. And if I put a block here, that's what negative. Let us hit this. This is what exactly your SR latch is, right? As I shown you earlier. Inside the circuit, you will have like this two NOR gate connection. This is what your SR latch is. Now you will be getting output Q and Q bar. So here, what here I have mentioned is output condition. So here you can see Q bar, Qn. It is said Q of n. That means it is just we are considering the time moment. We are moving along with the time, so it is particular time of instant. It means present. So when you can say it is Q of n, that is we are talking about particular moment n. That is, you can say it is a, what is Qn? It is the present output at time frame n, right? Time n, or you can say moment n. And this Q dash n, what this Q dash n is? This Q dash n, that is what another output. Okay, that is what it is, again a present output, but it is present inverted output. It is present inverted output at time n, means at the same time, you can say. Ultimately, this is what we are going to write down here. It is present output condition only when we are putting the n in bracket. Okay. Now you here, yes, please.
Excuse me, sir.
Yeah, please.
If we start the practical using this both gates, the NOR gates, do we need to simultaneously give input to both R and S?
Yeah, see, to give both means what? If you are not giving any input to the, it will be taking 0. When we say to give the input, ultimately what it says, when I'm saying that I'm giving here 1 and here it is 0, what that means? When you are giving 1, that means you are connecting some positive voltage over there at this circuit, right? Which having another point grounded. And when I say I'm giving 0 volt here, it is directly connected to grounded. This is how your wiring is going to be done. Right? Ultimately, when I'm saying 0 logic means it is 0 volt. And when I'm saying 1 volt, logic 1 means it is something 5 volt or kind of logic voltage there. So ultimately, wherever it is mentioned to give logic 1, there only you have to give the supply connection. Otherwise, it will be grounded. Is that what the answer you need?
Not exactly, but I got your point, sir.
Okay, so thank you. So now what I want to tell you is that whenever we are going to change these inputs R and S, that is called set input and reset input. So what condition you are going to apply here, it is not necessarily that you have to apply input at both the points, that R and S. For example, you want to just reset your output, then you need to give your input only here, that is at the reset terminal. At that time, your set input is going to be 0. There is no any input you are providing at that time. So at a time, only one inputs are going to be given. But let me complete this first truth table, so you will be getting your query solved there. Okay, so first condition which I am taking here, that is when your R and S both are 0, 0. Okay, so when your input R and S both are 0, 0, at that time What is the condition? What is the condition means? I want to tell you that what will be the output. When your R and S both are made 0, 0, at that time, as reset input is given here high, 0, and S is also 0, your output will remain Qn. Qn means your present output, and Qn dash means it is present inverted output. That both will remain at this value. Now that you have to understand here. It is Qn minus 1 and Q dash n minus 1. So we are talking about just before that moment we are talking. Qn, if let's say if I convert this into time, suppose we are starting this latch at some time equal to t equal to 0, and we are giving our signal S and R 0, 0 at time t equal to 1 second. So we are taking this Q of n and Q dash of n at 1 second. Okay. So Qn minus 1 is what? It is the value of your output Q at 1 second before, if you are considering that in terms of seconds. Am I making this clear to you or not? So you just need to get differentiate between these two. Here you understand the past and present. Qn is going to be your present output, and Qn minus 1 is going to be your past output. Ultimately, these both are the output which is going to come here only. Right? This Q is that what we are talking here. The output which is going to come here, that will be Qn when you are considering that particular moment, and whatever it is here, if you are considering just the back schedule, that will be Qn minus 1. So in short, what I want to tell you is that whenever you are going to give 0, 0 input for R and S both, at that time your output which is coming over here is not going to change. By writing over here Qn minus 1, it means that whatever output previously was coming at that value Q and Q bar will remain as it is. There is no change going to be there in that. Are you getting that point? So simply you may write down that also, no change. Here in remarks, you can put like that, no change come here in this case. So here you can say no change in the first condition when you are going to give input 0, 0. Now, second thing, when you are considering this condition, that when your R is 0 and S is equal to 1, at that time what will happen? Your R input is 0 but set input S is 1. So you are giving logic 1 here and 0 over here. Okay, so in this case what will happen? You have to understand this into two different cases. Let us say before you have applied this at the output here, let us say before you apply the S equal to 1 and R equal to 0 at the input side here, before that, let us say your output was coming 0 over here, okay, and 1 over here obviously. So what I'm saying, this is what I'm writing down here is your n minus 1 condition, right? This is your n minus 1 condition I'm talking. That before you apply this input, there was an input given 0, 0 as we have discussed, right? And so your output was 0 here and 1 over here. Let us say that was the condition. Now, if you apply S equal to 1 and R equal to 0, what will happen? This R equal to 0 will go here, and this S equal to 1 will go here, right? And at the same time, this 1 from the Q bar, from this line, it will come here, and this 0 from Q will come over here, right? Are you getting or not? And now what is the condition for NOR gate? Your NOR gate doing what? Hello? Hello, am I audible to everyone or not?
Yes, audible, sir.
Okay, be careful here what I'm talking. See, I'm just talking that whenever you are applying this zero input at the set terminal, sorry, logic 1 input at the set terminal and logic 0 at the reset terminal, and before that, when you are applying this signal at the input side, before that, just before that, if it is this condition you are having at the output side, that is q is equal to 0 and q bar is equal to 1, then what will happen here? Now you can see when you have given set input to 1, your output is going to be set. Output is going to be set means here right now what is the condition? 0. So your 0 is coming here from the Q, and you have given set input 1 over here. Now if you remember the truth table of NOR gate, your NOR gate will give you output logic 1 only when that both inputs are 0. So what this NOR gate will give you output? Because of here 1 as you have given, here 0 is you have been given, so this is output going to be 0. That means now it is converting from 1 to 0. And now that 0 will come here. So here R is only 0 and your 0 is came here. So 0, 0 will make your output to logic 1. So this is going to be moved from 0 to 1. And that's why what you can say, here output will be set and it is going to be reset at the inverted output. This is one condition I have talked. Now second condition, if you have already 1 over here, suppose you have already given 1 logic here and 0 over here before you apply this set and reset condition. Before I apply these inputs 1 and 0 here, let us say my output was already 1 and 0 like this. Then what it will be doing? You can see here that here S you have given 1 and this output 0 will come here. Output 1 will come here because it was only 1. So 1, 1 that will give you output 0 and that 0 will come here. So 0, 0 will give you output again 1. That means there will not be any change if you have already set condition. But if it is not having set condition, then your S input 1 will make your latch to get set at the output side. Now, am I making this thing clear to all or not?
No, sir. Can you explain?
Hello. Yeah, bro. Can you just let me know what you are getting?
For inverted Q, 0 1 condition.
Okay. Let's do one thing first here. You only consider one part here. You forget about this second part. Okay. Right now, we do not discuss about this inverted output. We keep it aside. Okay. You just keep focus on this here. That is what going to come here at the output side. Let me remove that part here. Okay, I'm just right now talking this output condition. First and most important thing that here your inputs are 2. Okay, when you have 2 inputs, you can have total 4 possibility, as we have already understood that thing, that your R and S both can be 0, 0. Your R and S can be 0, 1, or it can be 1, 0, or it can be 1, 1. That is the first important thing, that these are the 4 possibilities that we can give at the input side. Now, when you are having this is at the input side, we want to know that what will be my output Q. Output Q means coming here. Okay. Now, in this sequential logic circuit, it is not like that your output Q will only depend your input R and S. It is also going to depend on what was the last input combination. That means, suppose you are giving your R and S 0, 0 at this input condition. Okay. In that case, your output Q will remain Qn minus 1. It means whatever condition there it was given before you have applied RS 0, 0, that will remain as it is. If it was 0, 1, prior to your RNS given 0 0, if it was 0 1 here, it will remain 0 1 here. That's why I'm writing Q and minus 1. And if it was 1 0, then it will remain 1 0. No change will come. Whenever you are giving R and S, both are equal, in that case, your output will not get any kind of change. So this input combination will not providing you any change in the output. Is that condition clear to everyone first?
Yes, sir.
Okay. Now the second condition is, now you are going to give the combination 0 1. Okay. That means I am going to give R equal to 0 and S equal to 1. Now I have to take this condition with two output position. That is, let us say first my output is this one. That my output Q is 0 and Q bar is 1. That was the condition before I am applying the value R equal to 0 and S equal to 1. Okay. This was the condition prior to I am giving the R equal to 0 and S equal to 1. Before I given this input, my output was already Q equal to 0 and Q bar is equal to 1. Okay. So in that case, what will happen? In that case, this S will come here 1 because you are giving from outside, and this Q is only 0. So that 0 will come from here to input side because it's a cross conduction given already there inside. So this 1 0 given at the NOR gate will provide you output equal to 0. Okay. And that 0 will come here because it's again a cross connection. So 0 will here and 0 also already there from our side. So both are 0, and that's why this output is going to be made 1. Right? It means which was earlier 0, it has been changed from 0 to 1. And to change the output Q from 0 to 1 is called set condition. In case of sequential logic circuit, your output when changing from 0 to 1, we call it as a set. So set condition is happened here. That means your output Q has been set by your set input S. And as your Q has been set equal to 1, your Q bar is obviously going to be 0 at that time. That only we have got that. So are you clear with this first condition? Hello, your voice is not coming clear here. Hello. Still I'm not getting voice. Is that part clear? Yes, Dhruv, are you saying something? Dhruv, can you type in chat because I'm not getting your voice clear there? If anyone have another query, please let me know before we move further to discuss next part. Yes, Dhruv, we are checking set and reset condition by looking at Q output. If your Q is 0, you can say that your output is in reset condition. If your Q is equal to 1, you can say your output is in set condition. So if we are changing our output Q from 0 to 1, we call it as a set condition. Means we have made our output to be set. And if your output Q is going to move from 1 to 0, we call it as the reset condition. That means we are making our output to be resetted. Okay. So that's what I was talking here first for the case. Now, let us say second case is your output initially that was 1 0, not 0 1. Okay. Now this is not the condition earlier. Now the condition is this one. Before you apply this combination on the input side 1 and 0 for S and R, let us say your output was already 1 and 0 here like this. So what it will be doing when you are giving S equal to 1 here, okay, this 1 from Q will come here, and that 1 at the NOR gate input will make your output to be 0. That means it will remain same as it is, and that 0 will come here. So here it is 0 and R is already 0. So 0 0 will make output to be 1. So it was already 1 and that is remain now 1 only. That means when you are giving set input equal to 1 and reset input is equal to 0, at that time your output Q will be made equal to logic 1, irrespective of what was the previous condition. Previously, if it was resetted, then also it will make it to be logic 1. and if it was set, then it will be keeping as it is. It's not like that whenever set condition is applied here, so your output state is going to change. No, your output value of q will be changing according to the input. If you are giving set input to be logic 1, then your output will be made to be 1 only. If it is already 1, it will be remain 1 as it is. No change will come in that. Likewise, when you are giving r equal to 1, at that time your output q will be made to 0. If it is 1, then 1 to 0 will be converted, and if it is 0, then it will be kept as 0. Are you getting that part? So that will happen here when you give this condition. Now the next condition, when you are giving that your input, let me just take that here again, circuit. Okay, now I'm talking about the next circuit. Now I'm just removing all that part. We are talking now this condition, that when your r equal to 1 and s equal to 0, for that condition, what about your q that we are talking? So when your r is equal to 1 and s is equal to 0, at that time, then here also we have to check two conditions. Earlier, let us say your q is equal to 1 and q bar is equal to 0. I'm talking previous condition, before you have applied this r and s value, okay? So if that happens, what will be done here? This 1 will come here and this 0 will go here. So this 0, 1 will do what? It will give you output 0, right? So that 0 will come here and 1 from our side. So it will make what? It will give you output 0, because NOR gate, when getting 1 and 0 at the input side, it will give you output 0, right? And that 0 will come again here. So here 0, 0, that will convert your output q to 1. Are you getting? And if it is previously, if before you have applied this condition on r and s input, if it was already 0 here and if it was already 1 over here, this is the condition already exists, then what will happen? That this 0 which you are giving here to the s and this 0 will come here. So this 0, 0 will make your output to be remain 1, and that 1 when will come here, it will be giving 1, 1, so output remains 0. That means it will not going to change it. If it is having condition like this, then only it is going to convert it to 0, 1. But if it is already 0, 1, then it will be keeping it as it is. That's what I want to tell you here. For the condition, when you are giving r equal to 1 and s equal to 0. So am I making this thing clearly now?
Yes, sir.
Now the last combination, that is 1, 1, that you are giving r equal to also 1 and s equal to also 1. In that case, what will happen? That your output remains 1 or 0, it's not going to be stable, right? Why is that so? You can see that when I'm giving this output, let us say s and r both are set to be 1, 1, then what will happen? If I set s equal to also 1, r equal to also 1, and let us say previous condition, here it is 0 and here it is 1. So what it will be doing? This 0 when come here, it will be giving here 0, 1, so it will give you output 0. Now that 0 will come here, so 1, 0 condition will give you output 0. So that means your output, both output going to be 0 for the q as well as q bar, and that can never possible, right? That our signal and its inverted output both can never be 0. It means your output is going to be unstable in this case, and that is why in the logical operation in sequential circuit, this input combination is considered as a invalid inputs, or the output which you are going to get for this input combination is called invalid output. That's not going to be considered as a valid in your circuits. So for that, we are not going to give, or we are making sure in design that these two inputs will never come one at the same time. Okay, so this is what the logical truth table you can understand for this NOR logic gate SR flip flop. So is that clear to everyone? That what the, yeah, please.
Can we say in this condition we can only have one power supply and one other one is grounded?
On the input side you are talking?
Yes, sir.
Yeah, obviously you can say like that, but see, this is when you are actually going to circuit connect a hardware circuit. But when this is going to be there in a digital circuit and you are going to provide the signals from other circuits, at that time it's just going to be connected with the signal outputs. So it's not a question of their power supply, right? Ultimately, suppose I have some half adder or full adder circuits coming before this circuit. So that's circuit is going to provide you logic 1 or 0 based on the input condition of that circuit, and that's going to be stored. So at
Yes,
that
sir.
time,
What I'm saying is that we can only have at a maximum only one positive.
yeah, that's what I'm saying. Yeah, that your R and S, they both never can be logic 1 at the same time in this circuit, and that's why we have to design our circuitry accordingly, that they should not get 1 at the same time.
And can we also say that output is only one value, but with the opposite sign alternatively?
Yeah, see, your output Q is going to be either 0 or 1 only based on you are providing the set or reset condition on the input side. But what that output will be depending, that's what I made you understand here. See, that was I was talking about memory part. So I just taken you the two cases here, right? For each of the case, that when you, let's say your R is equal to 1 and S is equal to 0. So for this case, we have considered both the condition here at the output side. That is, if your output was already set, then what is the condition? Right. If I just give you that brief here, what I'm talking here, that if your R equal to 1 and S equal to 0, in that case, what your output should be? It is going to be 0 here and 1, right? That is what your final output. But this output is, you can see here, it depends on the condition, that what was the previous output. This is what you want, present output according to this present input condition. But if your previous output was this one, that is what you want to have in this present condition, then there is not any change you are finding, that what was the previous output, that is going to be there as it is. But if it was previously like this, then it is going to be converting that 10 to 01 in your present output. That means it is going to be resetting your output. Are you getting this point? What I'm saying? That
Yes.
it is not like that your output is always going to changing its state. Output will only change the state if it is not in resetted condition, for the case we are talking right now. So that's what you can say the behavior of memory. That means if your circuit is knowing that what was the past output, then only this can happen, right? And that's why it is called the smallest element of memory, that whatever output Q is coming here in this circuit is going to be kept stored till you are going to give you next input on the input side, R and S. Is that clear?
Yes, it is.
Okay, I hope every one of you are getting this working of this RS flip-flop. Now the same kind of working you can also have by using NAND gate, right? That you can draw like this. When I want, let me just take the figure directly so that it is not taking much time to draw it. Just a minute.
The question also arises that what will be the initial answer of the output of this circuit?
See, initial output, let's say your circuit is totally in rest, means it is totally in resetted condition, no power supply is given at all. In that case, obviously, your both the output is going to be 0, 0, right? When I'm
Yes.
just not connecting my circuit anywhere, means there is no any supply connection happen, then there is no any output, and no output means you can consider 0 volt over there. So in that case, your Q and Q are both can be 0, because it is just a resetted condition. But as soon as you apply a very first condition, that is either a set condition or reset condition, and that whatever going to set output or reset output, that is going to be remain as it is for the next coming inputs combination. Okay.
So in ideal condition, I mean in the rest condition, the circuit will store 0 0 as the output of the previous one.
See, the rest condition which I'm talking here, it is the very first time you are going to use inside your circuit. Once you are going to use that element into your circuit, that means once you have stored the data somewhere, Then after that is going to be remain there in that output, in that position Q, even after you remove from that circuit, right? Because there will be small storing capacity of your every circuit components, that amount of potential it's going to store, and that is going to be remain as a memory, you can say. Ultimately, if you take the example of your let's say magnetic memory, earlier we were using, if you having knowledge about that, somewhere we can having a cassette player, if you remember that thing. In that cassette player, what we are doing to store the data, there was a magnetic material over that tap, and that magnetic material position is going to be changed according to your data storing, right? Same way here, this is a digital storage. That's what we are using in our pen drive or hard disk or all the digital storage device. So that is going to include this kind of logic circuit inside only, and that is going to store your binary information in this manner only. That is the small circuits energy storing element will be there inside. Once you connect inside your circuit to store the data, that after whatever data has been stored will remain as it is. Means Q and Q bar, your question of initial data storage, initial value will going to change once you are going to change the inputs only. Are you getting my point?
Yes, sir.
Okay. So now what I want to tell you here is about the AND gate logic. Sorry, NAND gate logic. Here the circuit is not coming properly. Is it able to get united color? Okay. See here, the circuit I have taken directly from the net, so that I can use to explain you. So this is, I have to just add some part in this circuit. But this is going to be connected here, and this is going to be connected here. These are the NAND gates, okay? And here this NAND gate is used as a NOT gate. So if you want to implement that SR latch using the NAND gate, it has to be done like this. There will be requirement of this kind of 4 NAND gates, 2 for that cross coupling and 2 for the NOT operation. So now here, this is going to work like a circuit what you want to have. So that's what you have understood here. Let us say, suppose now I want to have my output Q to be set. So I have to give set input 1 and reset input to be 0 here. So what it will be doing, this is a NOT gate, so it will give you 0 here, and it will give you 1 over here, right? Because 0 to 1. And by that time, let us say my output was earlier 0 here and 1 over here. So what it will be doing, you can say that this 0 will come here at this input. So this 0 will be converting this output to be 0. So your Q bar will go to 0. And that 0 will come over here. So 0 0 condition for the NAND gate, it will give you output logic 1 here, right? It is a NAND gate now, it's not a NOR gate. So like this, it will be going to set and reset. So that's what the condition here you can see. When your set input is equal to 1 and, sorry, not that one, this one. Okay, in this case also, the 1-1 combination is going to be considered as an invalid, because when you give both are 1-1, at that time your output is going to be either both 1 or both 0. That's really, you can say, unstable condition, and that's why it is also considered as an invalid case in this also. And if you are applying 0 0 condition here on the input side, at that time what will happen, this both are going to give you 1-1 here, and that's why whatever input you have here, that will be kept as it is, right? So that is what, let us say, suppose here this 0 is coming. So here 0 1 will make your output to remain 1, and that 1 will come here. So 1 1 will make your output to remain 0. That means if it is 0 1 earlier, it will be kept as it is. For the case we are talking, when there is 0 0 input combination given here, it will not get any change, and that's why here it is written no change will come if you are applying this condition. In short, your output will be going to set. That means your Q will be made equal to 1 if your set input is given 1 and reset input is given 0. and your output Q will be made reset. It means it will be made equal to 0 when your set input is equal to 0 and reset input is equal to 1. So this is how you can have the flip-flop, or I should say latch, using NAND logic also. So this is called SR latch, using NOR gate and using NAND gate. Any one of this can work over there. So are you getting this, working of this both latch? Ultimately, see, output conditions will be same based on the input condition what you are providing, whether it is NOR logic or NAND logic. So is that part clear, everyone? Hello?
Yes, right.
Or is there any difficulty to understand this part?
No, sir, clear.
Okay. So if it is
No,
clear,
sir, all clear.
okay. Now let me take you to the simulation site where we are doing the virtual simulation. Okay. Okay. So now here in this, you have to do the simulation, and see here this waveform can also be make you understand. This is timing diagram, you can say. In timing diagram, you can see that you will be knowing that past and present input condition. Right. This is what initially you can see that your S is equal to 1 over here. Let me just take it to that screen itself. Can you see this SR input and Q bar output condition? This is the timing frame waveform, you can say. So here, when your S input is equal to 1, R is equal to 0, what it will be doing? Your Q is equal to 0 and Q bar is equal to 1. That is the first condition we are seeing, let's say. Then after, if you give your set input equal to 1 and R equal to also 1, what it will be doing? It is kept, it is 0, 1. Here it is actually considered for the negative logic, right? Means, I hope you understand the negative logic. This waveform actually plotted here considering the negative logic there. That means when you are giving set input to logic 1, your output is going to be resetted. Reverse task is happening here. And then when you give the set input to 1, it's converted, kept 0 as it is. When you give R equal to 1, it is going to convert it back to 1. And then you can see like this. Ultimately, let us make it clear by putting a notation here. Just a minute.
Is there a limitation or a disadvantage of the system that it cannot give output after a certain limit, or it is an advantage?
Just a minute, I am coming to your point. Let me just discuss about this waveform first. Just a minute. I'm taking it here. Okay, let us just put it together. Okay, now look at here. I have taken that waveforms here, so it will be easy for you to understand with the circuit. So now what I'm saying, that this Q and Q bar, we are talking about this two outputs. That is going to be either set or reset. Okay, here. These are the two outputs and these are the two inputs. Now initially, let us say we are having the condition at the output side. Okay, prior to this timing frame, let's say your S is equal to 1, and prior to this, let us see your output here, it is 0 and 1. Initially it is here 0 and here it is 1. So what it will be doing? When you are giving set input equal to 1 here, logic 1, and reset equal to 0. So for this time, what it is doing? It is giving you output logic high at Q, and Q bar is made to 0. Okay. Then after, if you keep set input for the next cycle also, then it will be keeping that q bar 0 as it is and 1 q as it is. Unless next time when you give q s equal to 0 and r equal to 1 here, at that time what it will be doing, it will be converting this to, you can say here it is 1 and there it is going to be 0. Are you getting? Then after, when again one condition comes, oh, I forgot to mention that negative logic. It's a little bit making confusion here as it is shown with the negative logic diagram. If I make, let me make it positive so you will not get confusion. Then we change it instead of 0 0, then I have to change that waveform as a whole. Just a minute. What can I do? Let me add two NOT gate here before it is applied to the circuit. This is going to be like this. You are giving your input like this. Consider this. So this waveform is actually drawn like this with a negative logic like this. So here this is what you are giving, your R and S. Okay, this is, let us say, R dash and S dash. Okay, and this is what I can say, this is the Q. It is like this now. Okay, so now you can see here, this is the waveform actually. Now I made it positive logic, though it is negative logic here. When I say this is S and R set equal to 1, your flip-flop is here or latch is over here. That is what it is getting, R dash and S dash as the input. Okay. Now when I say my S is equal to set 2 equal to 1 logic here, actually S dash is going to be 0 at that time, right? When I say S equal to 1, S dash is equal to 0. And if I say R equal to 0 here, I can say my R dash is going to be logic 1, like this. This is I am taking because this waveform is given as a negative logic. Negative logic means 0 and 1 conditions are given reverse. So I have to apply NOT gate over there to consider the actual working of this latch. So when this condition is applied, R equal to 0 and S equal to 1, at that time according to this waveform, your S dash going to be 0 and R dash is going to be 1. And that's why your output Q is going to be made 0 and Q dash is going to be made 1 here. Okay. Now when this 1 condition is applied here for S and R, they both is giving you R dash and S dash 0 0 condition. That's what the condition we are getting here on the input side of this latch. So as they both are 0 0, so there will be no change and you are getting this condition as it is. What is the previous output? Okay. Then after, when you are applying here 0 1 condition, it's going to do what? It will make your S dash equal to 1 and R dash is equal to 0. So it will be converting your output Q from 0 to 1 and Q bar from 1 to 0. Okay. Now here reset condition and next will be the condition that you are giving both are 1 1. So if you are giving both 1 1, then it will be keeping as it is. No change will be given. So it will be like this. Now when you are providing 0 0 condition on the input side, it will be giving what? R dash as well as S dash both are 1 1. And that is what our invalid case. And because of invalid case, here you can see the output Q and Q bar. It can be 1 or 0. It can be 1 or 0. And that's why it is come to invalid. Okay. And for that invalid case, what will be the next time? When next time you will be coming to the 1 1 case here, that 1 1 will make R dash S dash 0 0. So at that time there is unpredictable output will come, that unknown state, because prior to that whatever here it was 0 1 or it was 1 0, that you are not knowing. And that's why what output will come, that will not be predicted. And that's why this condition should never arise, that both the inputs of this flip-flop should never go to 1 1. So are you getting this? So in this time frame, if you look at here, for this we can say, if I consider in this one, if I'm considering this one as a present output, then this is what you can say past output, right? If you consider this one as a present, then this is going to be past, like that. So your flip-flop or latch output will depends on the past condition as well as the present input combination. So now are you getting this? What I'm saying about this timing diagram for this latch?
Yes, sir, it's clear now.
Okay. So in short, this latch is what you can understand is the smallest unit of your memory, and that is what you can say a sequential logic circuit, in which your output is going to be set or reset on two conditions. One, that is what you are providing at the input side, and second, that is what available already at the output side. Okay, so that's what the thing about this latch. Now let's go into the virtual lab verification. There you can see that virtual lab verification. So let us me share that virtual lab here now. Okay. Okay, now can you see this virtual lab here? That is I have taken in simulation. So in simulation, when you click on the simulation tab, it will be directly opening this page. Okay, here there is no other options there because here we are only talking about one latch. So it is based on construction using NOR latch. So I can connect the battery, and there are two NOR gates taken here, and that two NOR gates are, you can see, if I just remove the connection of battery, let us me reset make this condition if the reset is provided. Just reload the page. Okay, before the battery has been connected, you can see your Q and Q bar both are the LED in off condition, right? They both are in zero condition. Now once you connect the battery, they will come like this. Your Q will be set condition and Q bar will be zero. Now circuit connection is how it has been done. Your R input and S input is given with this two switch. R input is connected to the pin number 3 of the NOR gate here, and another input S is connected to the pin number 6 of the second NOR gate, right? And the output of both the NOR gate are taken here through LED, right, for indicating output. Now from the same output of the first NOR gate is given to the input of second NOR gate, and output of second NOR gate is given at the input of first NOR gate. That's what the cross connection we have seen in the circuit. So that kind of circuit is developed here. And now for this, you can check it what. Right now you can see the Q and Q bar condition is 1 0, and your S and R is 0 0. If you add it into the circuit, you can see that your output Q and Q and bar, that is having no change, right? But now if I make change, if I make R equal to 1, so what it will be doing? It's doing the reset condition, because earlier Q was 1 and Q bar was 0, but when I made R on, it has turned that Q to 0 and Q bar to 1. So that's what we can say in the table. And here also you can see that timing diagrams. That is what it is going to be developed here. Right? Now again, if I make S equal to 1, so here you can see your R and S both has been turned on simultaneously. That's why it is not taking the consideration here. So if you add here inside, you can see invalid output message will be displayed, and that is not going to be considered into your case. Right? It's considered as an invalid. And for that, what will be the output coming here? It's not predictable. And if I make S equal to 1, R equal to 0, then your output is going to be set. Whatsoever the condition prior to that, it will be making your output to set. Okay, so this is how you can verify your operation of your NOR logic SR latch with the help of timing diagram, as well as looking at the LED condition, as well as the truth table. Okay, so you check it for all the condition possible, and then you come to know that how this latch is working and how it is keeping output constants, or it is storing the memory data. So is that clear to everyone?
Yes, sir, it's clear.
Okay, so now let me share you the
Yes, sir.
link. You can just get it simulated in your device. So let us just take that link. Okay. Just open that link in your device and get it verified. Whatever theoretical aspects we have discussed regarding this SR latch, you can do it. Yes, Mahek is asking something that when will you add assignment of this practical in the canvas? Okay, there is no assignment for this practical, Mahek, inside the canvas right now. If it is not there, I will ask the I will ask the subject coordinator to add it. Okay. Okay, so this link is already given to you. Start verifying it. Check for all the conditions and clear your confusion, whatever you having regarding this. And if it is not possible by you to remove that confusion, you can ask me here. I will give you the answer. Okay. Okay. Okay, I think now all of you should have verified it and got to know that how this latch is going to work. Is that right? Hello.
Yes, sir. Done with it.
Okay, what about
Yes,
others?
sir.
Okay. Vasu, have you done it? Vrinda, have you completed that? Hello, Vrinda, can you hear me?
Yes, sir.
Yeah. Manthan, have you done it? Hello, Manthan, can you hear me?
Yes, sir.
Have you done it?
Yes.
Can you just show on screen by sharing it so that everyone can just come to know? Hello, Manthan, just start your screen sharing. Yeah. Okay. Okay, Manthan, if my output is right now resetted, that is 0 and 1, okay? And if I give the input r equal to 1 and s equal to 0, what should be the output condition? Hello? You got my question? I'm asking that my output is right now resetted, that is 0 and 1. Q is 0, Q bar is 1. In this condition, now I'm applying the input r equal to 1 and s equal to 0. What the output will have the change? Hello? Are you getting my question? Anyone can give the answer, not only Manthan, right? Hello?
Sir, can you repeat the question?
I'm saying that my output is Q equal to 0, Q bar is equal to 1. And in that condition, I'm giving my input R equal to 1, S equal to 0. What will be the output? Yes. Can you give the answer now, man?
So not getting your question.
I'm saying you that in my SR latch, present condition of output is Q equal to 0 and Q bar equal to 1. That is what condition right now. And now I am giving the input that R equal to 1 and S equal to 0. So what will be the next output at that time? Still you are not getting the question. See, you just look at the truth table that when your output is 0 and 1, that means it is already in resetted condition. what we call it for when your q equal to 0 and q bar is equal to 1, we can say that output is in resetted condition. And in that condition, if you are applying r equal to 1 and s equal to 0, that is what the input for making your output to reset. But your output is already resetted, so what it will be doing? It will keep your output as it is. No change will come in that. That's what your answer should be. Are you getting what I'm asking?
Yes, sir.
Hello. Okay. Anyway, this is the first time you are coming across this sequential circuit, so it might have some doubt created in your mind, and you are not able to get 100% it. But don't worry. You just go through that part from the books. Just read out that topics, and still, if you are getting any confusion, any doubts for this SR latch in your mind, please come up with that in our next session. Okay, that also we'll be discussing about that. So that's all from my side today for this lab session. If you have any query, just let me know. Otherwise, give your attendance and then you can leave. Thank you all. We'll meet again in next session.